I'll just make up some data. It's not true. Anybody hear what happened out at Wyoming the other day, weather-wise? They got a snow. Nobody heard about this? Oh, this is kind of cool. Not everywhere, but they got upwards of 3 foot of snow in some places. 3 feet is like that deep in one snowfall. So, let's take a look at, and I'm making up this data at this point because I really don't know what the rate of snowfall was at various points in time, but we just need some data to work with. So let's say time and depth. And let's say at 10 a.m. at noon. Are you comfortable with working military time? Like 1400 hours is what time? 2 p.m. 1800 hours is 6 p.m. Why do they do that weird stuff? So they don't get confused. Yeah. So imagine that you got something going on, that you need some air support or artillery or something like that, and you need it at 6. Okay, if things get scrambled up and you're needing it 6 a.m. but they don't show up till 6 p.m., is that a problem? Yeah, it can kind of really change your day. So to prevent that kind of stuff from happening, they went to the 1400 and 1600 and 1800, like that. Okay? So we'll use our hours like that just because it makes it easier than trying to deal with 2, 4, 6 showing up again and all that strange stuff. Okay, depth, I'm just making this up. I really don't know what the snowfall looked like or whatever. But let's say at 10 a.m. there wasn't any snow. Let's say by this point there was 11 inches. At this point, let's say the total accumulation was 25 inches. And let's say 36 inches. And then say here 37 inches. So this was the snowfall over the course of the day, between 10 in the morning and 6 in the evening. Just making it up. They really did get 3 foot of snow, which is pretty neat. If you were asked to compute an equation to fit this data, okay, you would want to do a regression. Regression is a fancy word in math that just says, hey, come up with an equation that pretty well fits this data. Okay. So the first thing you want to do is you want to graph your data so that you have some idea which shape it is. Before I graph it, I have to know which of these is X and which is Y. So the way to pose it is, hey, it's 6 o'clock. There are 37 inches of snow. Okay. Reverse it. Hey, there are 37 inches of snow. It must be 6 o'clock. Okay? Just because there's 37 inches of snow, you get the idea. Okay? So what that allows you to conclude then is that X time is going to be in control of the depth of the snow. Bless you. Okay? Makes sense to everybody? So we can go ahead and put some numbers down here. So we'll do 10, 12, 14, 16, and 18. Then we'll do, let's say 10, 20, 30, and 40. And we're going to plot our data. So at 10, no snow. At 12, it's getting on a little bit, got 11 inches. At 1400 hours, 25 inches. At 1600 hours, 36 inches. And 1800 hours, 37 inches. apart from that last piece of data, what kind of an equation does this look like might fit it? Linear. Okay? Do you see that you could fit a line through there? And a line would not be a horrible fit even with that last piece of data. Because if you look at it, the miss by the last piece isn't too much different than the miss at the 1400 hours, is it? So you got a little bit high, a little bit low. A linear equation may not be too bad. Okay, well, if you're going to do a linear equation, we need to recall that we're building something like y equals mx plus b. Oh, yeah, we need a slope, don't we? How are we going to get a slope? Yes, sir.
Choose 2 points, so 12, 11, 14, 25.
Yeah, pick 2 points and...
Don't matter which point.
Well, yeah, and Myron's saying, well, does it matter which 2 points? It depends how much time you have. Okay, I'm looking at the time thinking, I got other stuff I really want to get you through today. One way to do it would be to compute the slope from here to here, slope from here to here, the slope from here to here, the slope from here to here, and take them and average them. Okay? So you would have 4 separate slopes, average them, see what you come up with. What I'm going to do is I'm going to kind of cheat, and I'm going to do the slope from here to here as one computation. And I'm going to do the slope from there to there as the other computation. Okay? Now let's just see what happens. So the slope from this is going to be, well, we've got 25 inches at 1400 hours, and we have 0 inches at 1000 hours, which gives you 25 over 4, which is going to be 6.25. Now, this slope really means something. Recall that there were units on these numbers. This was inches, and this was hours, and this 6.25 is going to have what units on it? Isn't it going to be inches per hour? What's that mean? 6.25. Yeah.
It means that every hour is 6.25.
Yeah. Between 10 in the morning and 2 in the afternoon, during that 4-hour time frame, you're getting an average of about 6 inches an hour. That's what that means. Now, does that mean that that's exactly the way the snow fell? No, it might have stopped for a while, might have been heavy for a while, might have been flurries. You get the idea. Okay? We're going to play the same game with this one. Here, the slope is going to be this 37 inches at 1800 hours minus the 25 inches at 1400 hours. Well, this looks like this is going to be about 12 over 4. So this looks like this is going to work out to be 3 inches per hour. Does that make sense? We have 2 different slopes there, don't we? How are we going to choose the better one? We could average them. Okay. Now on this one you could also say, well, I really don't want to use this last point because there's basically no snowfall that last 2 hours, was there? And what you could do is you could say, instead, I'm going to use this point and this point, which is when it looks like the snowfall was still fairly significant. And you could do a slope between those. Does that make sense? Without having the machinery to do the number crunching stuff fairly painlessly, it gets to be more of a guessing game. And quite candidly, it is a guessing game. Okay? But what I'm going to do here is I'm going to go ahead and talk about the entire time frame. So I'm going to take these two, add them together. So the average is going to be the 6.25 plus the 3 over 2 gives you 9.25 over 2 gives you 4.675 inches per hour. So what this is suggesting is that on average over that entire time frame, from when the snow started until it basically stopped, on average you were getting how many inches of snow an hour? Yeah.
Wait, where did you get the 9.25?
When you add these two numbers together.
Oh, yeah,
Yeah. Does that make sense? Because we're doing an average, so you just add them and divide by 2, just like what you do with grades or something. Okay. Remember, what we're trying to do is not just compute a slope, but we're trying to get the equation of a line that would sort of fit that. Well, we now have a slope. This value goes in there. Make sense to everybody? So we now have y equals 4.675 x plus b. And what we now need to do is to pick a point that's probably not too bad of a choice for a point on the line. You might have picked a different point than me. That's fine. Your equation will come out a little bit different than mine. Yeah, you'll get different answers as you choose different points. That's fine. They're going to be sort of close.
Oh, somebody didn't know like right or wrong answer.
Right, there's a whole series of answers. Yeah. Whoa, get out of here. You mean there are 5 or 6 different answers possible on this one? Yes, there are. Well, which one's right? Any of them are. Where should we go get something to eat? Skyline? McDonald's? We could list 5 or 6 places, couldn't we? Parker's Grill. Trying to think what else is around here. Is there one of those 5 Guys? Anyway, you get the point. And the question would be, you know, well, where you want to go, and you list 5 or 6. Is that any one of those wrong? No, they're just different options, aren't they? Same thing with this. Okay, so what I'm going to do here is I'm going to pick this point. Right here is my point I'm going to use on the line, which means that we're going to have an x value of 16. So we have 4.675 times 16 plus b equals, and it's 16. What was the y value? It was 36. So I have the 36 for the y value. Everybody good so far? Yeah, I just picked that one because it might fit well. You could pick other ones. Okay, so what we're going to do now, or what I'm going to do now, is I'm going to solve for b. Well, we have this 36 equals, I have the 4.675 times 16 equals, we have this 74.8, yeah, plus b. And when you move the 74.8 to the other side, you're going to get a negative 38.8 as the b value. Mm-hmm. This then gives us an equation, y equals 4.675x minus 38.8. You okay so far? From this then, a real fair follow-up question might be something like estimate the depth at 1 p.m. And remember, 1 p.m. is what time military? 1,300 hours, isn't it? So it would be 13. Well, to estimate the depth, all we have to do, remember the y value is the depth. How do I know y is the depth? Well, go back to our data. See up here? Y is the depth. The upper left corner there. 1,300 hours. What should our estimate of depth be at 1,300 hours? What should it be around? Not perfect, but in what range? Well, it's bigger than what? Bigger than 11 and smaller than 25. It's somewhere in that range, isn't it? So maybe like 18, something like that. Okay. If we come up with a value of 48, is that possible? Okay, that would be kind of strange. That would mean that the snow got up to 4 feet deep and then came down to 3 feet. I guess a foot of it melted or blew away or something or other. Okay, so as you're working on these things, make sure that what you're saying makes some sense. Around 18 inches would probably work here. Well, let's try it and see what happens. We're going to do our depth is equal to 4.675 times 13 minus 38.8 equals, let's see here, 4.675 times 13 subtract 38.8 equals, okay, 22. It's in range. It's a little high. Okay. Remember, it's just an estimate. Your estimate from a different equation might be a little low. That's fine. It's just an estimate. We really don't know what's going on at 1 o'clock. If you had a heavy snowfall early and then just a light dusting till 2, or if it was light early and then a heavy blast, or if it was even. But this is one estimate of the depth of the snow at 1 p.m. Does that make sense how that works? Okay, yeah.
The reason why you said 1 p.m., right, 13 hours,
Mm-hmm.
and they'll say time. So the reason why you had to plug in 13 instead of 1 was because the data was set up in military time.
That's right. Yeah, Myron's saying, well, wait a minute, why did we plug in 13 instead of 1? And the reason is because our data was all set up using military values for X, so we needed to stick with that same pattern when we substitute our own values in later. Is everybody good with that? Makes sense? Does that help some on what's going on with this regression stuff? That R word, whatever it is?
They should change that regression.
We went over this during class one day, so is there a movie about how to get on there?
There should be.
Okay.
Yeah, I think there's a movie for just about every day. Does everybody know where these movies are?
Yeah, it's on YouTube.
Yeah.
Okay, do you know how to find them? Well, I know where they are. They're in Sweden. But exactly where, I don't know. Okay, let's take a look at this. This will be part of the movie, so if you forget, it'll be part of the movie. Ah, looky here. One of the other classes asked. You're not the first folks to ask. How'd I get here? I went to Canopy. Everybody knows where that is, right? Then I picked college algebra. Yes, I know this one says applied calc. It was an applied calc class that asked. Yours works the same, except you just pick your college algebra class. Once you pick your college algebra class, you click Course Notes. When you select Course Notes, it'll bring you to a page that looks just like this, and you will see, well, the first couple of them, it's in black on the link, but you will see here a link to the notes. It's a PDF. You can print them out. And what that PDF is everything that I've written down, and it's been projected on the screen. The second thing that you will see for each class, there may be 1 or 2 words missing, is a link. You can either just directly click on that link or copy it and paste it in for the URL, and it'll take you right to where the movie is. Just press play and it'll start. It's that easy. Now, one of the nice things is, just like with YouTube, they got 5 minutes of talk, and then the cat finally makes the dumb jump, and you go whoop and move it forward. You can move it forward to wherever you need to be, or backward, or whatever you need to do. So you can move it around, but all you have to do is go to this page. It's listed as course notes. Click the link, and bingo, you're there. Yeah.
So is the quiz on Friday, is it going to be over regression?
It won't be over regression. It's going to be over the stuff we're working on now. So section 2.5, I'm hoping, I don't know, we'll see. We might be able to get into 3.1 today. Okay.
So the quiz on Friday gonna be like everything gonna be from 2.5.
Yeah, it's going to be 2.5 because last week was the 2.4 stuff, the modeling, the linear regression, and last Friday the way we did a quiz on linear regression and data was by doing the bungee egg jump. Okay, so that was your quiz on that. So that's got that squared away. And everybody's good now with where the movies and notes are? Okay. Also, see here where it says tests and quizzes? If you click on that, it has a blank copy of each quiz, as well as a PDF with the answers written out. Ooh.
Which quiz? Like the quizzes?
The quizzes you've taken.
The quizzes we already taken.
All of you've taken. Oh, rats, not the ones you're going to take. That'd make it easier studying for the quizzes, wouldn't it?
Yeah.
Okay, but the answers are there. And I purposely include the blank copy so that you can just print a blank copy and you can take the quiz over and over and over and over. And then you've got the answers printed out there as a PDF. You can check the quiz and see how it's going.
Oh, that's a good thing to use for like the final exam to get prepared for the
That's
final
right.
exam.
Or for the tests. It's great for I'm hoping it's useful for the tests and for the final both. Yeah. And that's why it's there like that. Everybody good? All right. Let's jump into what's going on here with section 2.5. After 2.5, we're moving on to 3.1. Yahoo. Okay, so on to section 2.5. 2.5. Let's try writing 5 a little different. Deals with absolute values. Absolute value deals with a measure of the distance between two numbers. It does not tell you if one's to the left or one's to the right. It just says they're this far apart. When you go to something like MapQuest or Hey Siri, directions to, I don't know, I guess we're headed to Cleveland here soon for a hockey. Okay? So I'm just going to say, hey Siri, directions to, and then whichever ice rink it is. And it'll come back. Uh-oh, Siri's tuned in. Okay? It'll come back and it'll give the mileage and it'll tell the time and all this stuff. Okay? And when it gives the mileage, it doesn't say, are you going from north to south or south to north, does it? It just says 136 miles. Well, that 136 miles does not pay any attention if we're going south headed north or going north headed south. It's just 136 miles. It's how far it is between those two cities or locations. The same thing is true with absolute value. It just tells you how much distance there is between the two things. Okay? Without the negative, it doesn't tell you if you're moving positive or negative. The idea of removing the negative is it allows you to just see the distance between them without knowing what direction you're moving. Okay? With absolute value, you got to be careful when you're working with these things. We talked about graphing them the other day. Spent a chunk of time on graphing. Okay? When we get into quadratics, you're going to see that same basic discussion with regard to graphing all over again, except with parabolas, and I'm hoping it'll start to sink in and you'll see the pattern. There's a pattern to these on doing these graphs by hand. They're actually pretty easy once you get the hang of it. Okay? But let's take a look at some things like this. Let's say we have the absolute value of, let's say, 4x plus 3 equals 27. Now, where'd you get that, Chuck? This is question number 30 in the homework. Okay, question number 30 in the homework. So what I figured I would do is just pull a couple of them out of the homework, even numbers, so that if you go back to look at any of these problems, the odd numbers are answered in the back of the book, but the even numbers, not so much. So I'll give you some additional problems to practice on. How do you handle these things? Well, first I'm going to write that 7 so it looks like a 7. With absolute value, inside, you could either have a positive or a negative 27, couldn't you? Whatever is inside could have been either positive or the negative of 27, but with the absolute value signs, it removes the, if it was positive or negative. Does that make sense? So when you have something like this, you need to remember that there are two options. One option is 4x plus 3 equals 27, which will give you 4x equals 24, which will give you x equals 6. The other option is this 4x plus 3 could have been equal to what? Negative 27. Subtracting the 3, you'll get that the 4x is a negative 30, which gives you x is equal to a negative 7.5. So it gives you two different values, each of which will work in there. Does that make sense why you need a couple, the positive and the negative, to solve this? Okay. If we had something like this, I'll jump down to number 40. It's a fairly quick one, it looks. If you have this absolute value of negative x minus 4 equals 0, okay. Well, we could set this up one of two ways. Wait a minute, can we set this up one of two ways? Yeah, did we need a negative 0? Nah, it's in the same place the positive 0 is, isn't it? No way, get out of here. You mean if we wind up with a equaling 0, you only need to solve it once? Yes.
So after you add 4 to a 0, it's going to change.
Well, things are going to move around here a little bit.
Change it to a 4.
We're getting negative x equals a positive 4. And then now we need to multiply both sides by negative 1. And we get negative 4. Really, Chuck? Does that work? Let's test it and see. We're going to do the absolute value of the negative of whatever x is minus 4 equals 0. And what are we claiming the value of x is here? Negative 4. The negative of a negative is a positive. So what this gives us inside the absolute value is 4 minus 4. Does that equal 0? Sure enough does. Are you okay with solving problems like that? Something else can happen. Let's go back to the graphing that we were doing the other day. Let's say we have something like this. We have an absolute value with the vertex, with the vertex sliding away on me. Like that. The vertex is at 3, negative 1. It's entirely possible that we might want to know, for example, where this is greater than 3. Now let's make it 2. Pick a different number than what we're working with. Where is it greater than 2? In other words, if we draw the graph y equals 2, the question is, where is that graph above 2? Well, it's above the graph over here, isn't it? And it's above the graph over there. Does that make sense? So one of the places where it's above the graph is to start there and move in that direction. The other place it's above the graph is to start here and move to the left. Oh wow, this is going to be kind of weird. The answer goes to infinity and it also goes to negative. It has two different portions to it. Does that make sense? Okay, so what does this function look like anyway? Well, we can use our absolute value because we're working with our absolute values, and with a v, it's definitely an absolute value. In the x direction, we move to the right 3. Inside, do we need x plus 3 or x minus 3 to shift the vertex to the right 3? We want to move to the right. Okay, yeah, and it's kind of strange. Let's try this. Let's experiment. X plus 3. Now, where would that equal 0? If we plug in, what value of x would we have to plug in to zero that out? Negative 3, wouldn't we? Okay, so that would move us over to the left, negative 3. So that's fine. We're experimenting. Doesn't matter if we have to erase. That's why they make erasers. If we try x equals a negative 3, now what value of x do we need to put in to zero it out? Positive 3. Does that move us in the direction we want to be? Okay, so that's good. Notice, is it okay to make mistakes? Yeah, just correct them. Think about it. And if it doesn't make sense, that's fine. Change it. It's no big deal. Okay. Yeah, why the minus 3? Okay, what I'm looking at is, originally, when we start out, absolute value of x lives there. We've got to make some changes to the function to move it from where that thin red v is over to where the thick blue v is. One of the changes we have to make is to put an x minus 3, and what that does is it shifts it 3 units to the right. Now we also need to do one more thing. We need to shift it up or down? Down, because we're below the x-axis, aren't we? Does that make sense to everybody? To shift it down, we're going to put a minus 1. There's our function. Are you good? Okay, so here is the function that we're going to use for our particular graph. The question here is, where is the absolute value of x minus 3 minus 1 greater than or equal to, we'll put in equal to as well, so we can actually include the point 2. And what that's actually asking is to locate, where's this point? Where's that location? Does that make sense what we're looking for? Yeah, but where would we ever have it greater than or equal to something? Well, if we want to go on a vacation and we want to get at least 100 miles away from home, we'd put the distance from where we are to wherever we're going has to be greater than or equal to 100. And we'd use absolute values because do you care what direction you're going? Nope, just want to get away from home for the weekend. I don't care if I go north, south, east, or west. Okay, just got to get away for a little bit. Does that make sense? Okay, there are various applications. Just a quick example of what it means. Okay, so how do we solve this? Ooh. Well, that absolute value part's kind of a problem. How about we do this? The absolute value of x minus 3 is greater than or equal to 3. Where did I get 3? Where did that 3 come from? See this negative 1? I added 1 to this side, which means add 1 to, oh man, that's just standard algebra stuff. And what that does is it gets the absolute value by itself. You want to get the absolute value by itself. And once you do that, now what we can do is we can say, okay, I want this x minus 3 to be greater than or equal to 3. If what's inside of the absolute value is 3 or bigger, we're good to go, aren't we? If it turns out to be 4 or 5 or 10, do you see that that'll give you something bigger than 3 coming out? Now, here comes the part that's kind of strange. X minus 3 less than or equal to a negative 3. What that's saying is, if what's inside of this absolute value is negative 3, negative 4, negative 5, that's also going to give us a result that's bigger than 3, isn't it? Does that make sense to everybody? Oh man, we're back to 2 options. Okay, so let's solve it with option number 1. This gives us then that x has to be greater than or equal to 6. So one option is over here at 6. We could start at 6 and go to infinity. The other option is over here where we're going to add 3, which is what we did in the last one. But the results are going to be a little different this time. Here we're going to get x is less than or equal to what? 0. Which came pretty close. There we go. I'll kind of fudge the dot a bit. But you want to start at this point 0 and go that way. Okay, so the question now is, how do you write the answer? Well, we talked about some things like this earlier. On the left-hand side, the answers go from negative infinity over to what? Don't they go over to 0? Does that make sense? So that part is going to be from negative infinity over to 0. Can we actually include 0? Yeah, because it's a less than or equal to. I'm intentionally saving some space here in the middle. Then we can start at 6. Can we include the 6? Yeah, good. And from 6 we're going over to where? Infinity. Can you include infinity? No. To say that it can be the stuff on the left or the stuff on the right, you use the union sign along with. Any x value in either of those two regions will work. Does that make sense? It's kind of sneaky solving these things with these inequalities going on, isn't it? Okay. The cool thing here is if you have one of the graphing calculators, you can graph the function. So if we knew this was the function, we could put that in, graph it, and then we could also graph, do you see this y equals 2? That's a function. Passes a vertical line test. It's a function. So you could do the graph with the absolute value on it, and then the line coming through. Find where the two intersect, and that'll be 6. And you can see you want to be 6 or to the right of 6, so we're above it. Find the intersection on the left, which will be 0. And we know we want 0 or to the left of 0. And that'll get it done for you. So you can look at these things either algebraically or graphically and get a solution for it. Let's try something like this. I'm going back to the homework. Okay, and this is in section 2.5. Let's do an even numbered one. How about something like number 84? Ooh, that's got to be hard. It's a pretty big number. 84 says the absolute value of negative 3 minus 6x has to be bigger than 9. Well, go get them. See what you can do with that. What are you going to do with that one? Well,
I just switched around with the -6. I did -6 minus 3.
okay,
-6 first, 6x first.
minus 3. So you swap that around.
And then I did
Greater than
and then front down
9. Okay. Does that work for folks?
Why'd you switch it around?
Because he didn't like the other way. That's kind of dangerous. You can't always swap around. Oh, that's right. 3 minus 2 isn't the same as 2 minus 3. I think you can get away with it this time. But what he was trying to get away from was dealing with this. You're much safer to just stick with that because it can get you into some ugly things at times. Not always, but at times. It's okay. I was going to mention it anyway, so thank you. Okay? The other option is this minus 3 minus 6x. Let's see, we're going to need the negative 9, aren't we? Do we still keep it greater than, or what do we do this time? Less than. And the reason for that is, if we want to be bigger than 9, that means we're looking out on that end of the number line, aren't we? The flip of that would be to come over to negative 9, and we no longer want the bigger than part because that would be in that direction. What we want is now we want the smaller than. Like negative 10, negative 11, negative 12, things like that. Okay, so let's see here. First thing we can do is we can add 3 to each side. We have negative 6x is greater than 12. Now what do? You divide by negative 6 and get x is less than negative 2. Everybody good with that? Go to the other side. Well, let's see here. We can add 3 just like we did before. And that's going to give you a negative 6 is less than negative 6, well, negative 6x, sorry. Negative 6x is less than negative 6. Then when you divide by the negative 6, you're going to get x is greater than 1. Okay, so how do I write that out as an answer? Well, we want to either start at 1 and go to the right, or start at negative 2 and go to the left. Which means that we're going to do this negative infinity to negative 2, and since it's strictly greater than or strictly less than, we'll use parentheses. And along with that, we're going to do from 1 to infinity. There's your answer in set notation. Does that make sense how that works? Okay. Realize that you can do these things, solving them with a graph. You can do these things just with normal algebra. The only thing you have to be aware of is that you're going to start out with two separate problems to work on. Unless it's equal to what? 0. Okay, 0 cuts you down to just one option because negative 0 and positive 0, same thing. Are you okay? Probably owe you a minute or two. Looks like we're about 2 minutes early, but let's call it quits here. Friday's quiz will cover this stuff with absolute value. Okay. Then Friday we will jump into section 3.1. The homework is all due October 25, so that gives you some time to work on it. I would encourage you to get it taken care of before the test instead of after the test. And if you'll notice, I'm pulling some of the problems out of the book. You may want to either online or in the library take a peek at the book and work on some of those problems too if you need some other practice. Okay? Folks, I hope you have a good afternoon. I'll see you all Friday. Wow. Friday it is.